In this video, let's practice solving some logarithmic equations together. For these particular logarithmic equations, we're going to have to know a little bit about quadratics to solve them. Let's take a look at number 1 together. In this equation, we have log base 6 of this x squared plus 4x plus 4 is equal to 2. First thing I'm going to do here is rewrite this equation and identify that our base of the logarithm is going to be a 6 here. The reason why that's important is we're going to take that base of this logarithm of 6 and exponentiate both sides using that base of 6. By exponentiating, I mean we're going to take the left side and use 6 as a base and rewrite the left side as an exponent. And on the right side, we're also going to use 6 as the base of the power and then raise it to the right side, which is that 2. At this point, you're going to want to remember that when we use our inverse property, this is going to cancel out. And we're going to be left with this part of our expression on the left side of the equation. So using our log properties, we know that this is going to cancel out. And so we're going to have this x squared plus 4x plus 4 on the left side, and then 6 squared on the right side is going to be equal to 36. Taking away 36 from both sides of the equation, we're going to get x squared plus 4x minus 32 is equal to 0. And if we factor this, we get the quantity of this x minus 4 times the quantity of x plus 8 is equal to 0. And if we set each of these binomials equal to 0, we're going to find out that x is going to be equal to 4, and that x is going to be equal to negative 8. So these would be our two solutions. Let's try another one together. Here is number 2. For this equation, we have log base negative 2x minus 3 of the quantity of 3x squared plus 2x minus 15 is equal to 2. Just like the last example, we want to notice what the base of the logarithm is. In this case, we have this negative 2x minus 3, so it's a little bit more complicated looking. Even though the base looks a little bit more complicated here, we're going to go ahead and use the same property that we used in the last one and exponentiate both sides. Using our base of negative 2x minus 3, and make the entire left side of the equation an exponent, and then we're going to go ahead and use that same base of this negative 2x minus 3 on the right side, and take the right side of the equation and make that an exponent. Let's go ahead and just put this in parentheses though. Just like in the last example, we want to remember that from our inverse property of logs that this is going to go ahead and cancel out, and we'll be left with this expression on the left side of the equation. So on the left side of the equation, this is going to go ahead and cancel out. And we're going to have this 3x squared plus 2x minus 15 on the left side of the equation. And on the right side of the equation, we have this negative 2x minus 3 raised to the second power. So let's go ahead and just expand that real quick. Then on the right side, if we go ahead and FOIL, we're going to get 4x to the second power. Then we're going to get this plus 6x and then plus another 6x. And then we have a plus 9. Combining like terms on the right side of the equation, we're going to get 4x squared plus 12x plus 9. And now hopefully we can notice that we have a quadratic equation, so we want to put everything on the same side of the equation and set it equal to 0. Moving everything to the right side of the equation, we can start by subtracting 3x squared from both sides, taking away 2x from both sides, and adding 15 to both sides. If we do that, everything on the left side of the equation is going to become 0, and on the right side, 4x squared minus 3x squared is just going to be 1x squared, or x squared. 12x minus 2x is going to be a positive 10x, and then 9 plus 15 is going to be 24. At this point, you can go ahead and try a different couple things with solving a quadratic equation, including completing the square, or you can try using the quadratic formula or factoring, but this one does happen to factor nicely. And if you factor this, we're going to get 0 is equal to the quantity of x plus 4 times the quantity of x plus 6. Now setting each of these binomials equal to 0, we can use a zero product property and say that x is going to equal negative 4 as one of our solutions, and then x is equal to negative 6 for our other solution. These would be the two solutions for this quadratic equation. So there you have two different examples of solving logarithmic equations where we had to apply our understanding of quadratic equations as well. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep with the great work that you're already doing, and I'll see you in the next one.